Hi guys, and welcome back. So far we've talked a little bit about the basic structure of what a Kubernetes manifest file looks like and how you can discover the different API groups and the different types of resources that you can define on your Kubernetes cluster dynamically by discovering those using the kubectl command line utility. Now, let's actually talk about how you can go about deploying one of these manifest files. So to deploy a manifest file, what we're going to do is use the kubectl command line utility. So you would just run kubectl, and then you can run this command right up here called apply, and that will apply a configuration of a resource based on either a file name or from standard input. So anything that you pipe into the kubectl command line utility, you can use that to apply resources onto your cluster as well. So over here on my remote Linux server that I'm SSH'd into, I'm going to go ahead and just create a new file. And I'm just going to call it mycoolpod.yml. And I'll hit I for insert mode in Vim. And then I'm just going to take this pod definition right here, copy it to my clipboard, and then bring it over into this file and just paste it in. And then I'm going to go ahead and just save and quit Vim here. So now I should have this file. If I just do cat mycoolpod.yaml, you can see I've got this file right here on my local file system. So now if I wanted to actually deploy this pod configuration from this manifest file that we've created, all I need to do is run kubectl apply, and then you'll see it says you must either specify -f or -k. And if you're not sure what those options are, you can always run --help on kubectl apply, and that's going to show you all of the different supported parameters here. So if we take a look at -f, that's short for file name. So you can actually specify an array of files that you'd like to deploy. So you can deploy just one file, or if you have 2, 3, 4, 5 or more files, you can specify those as an array of file names as well. And then if we take a look for the K option, this allows you to use a third-party tool called Kustomize, which has since been incorporated directly into kubectl now. So it's actually native to kubectl now, but it initially started off as a separate project called Kustomize. And this is actually like a templating engine. You can kind of think of it almost like Jinja templates if that's something you're familiar with. And you can basically apply customizations, inject variables into your configurations, your manifest files, I should say, and pre-process those before you actually deploy those out to the server. But the most common option that you're going to come across is simply defining your manifest as a file and then using the file name parameter to apply that to your server. So let's go ahead and give that a try. So we're going to do kubectl apply --file name, and then I'm going to say mycoolpod.yaml, and let's see what we get back. All right, so it looks like our API server has created this new resource on the API server. So that looks good. And now what we could do just to verify that, we could say kubectl get pod. That's going to show me the pods that are running on my server, and as you can see, it created that pod for us. Now, you can also use these manifest files to actually delete resources from your API server as well. So if you run kubectl again, and you look for the delete command right here, this allows you to delete resources by manifest file names or from standard input, for example, or you can define resources directly by the resource type and name on the command line. But we're gonna focus on manifest files here, so we're gonna actually delete it based on its file name. So I could do kubectl delete --help, and this also has a file name parameter on it. So all I would need to do to delete that pod from my server is to pass in the exact same file name here. And essentially what's going to happen here is kubectl is going to scan through that list of resources in that manifest file, and it's going to find a pod definition with the name property of mycoolwebapp, and then the API server is going to say, hey, I've got a pod running named mycoolwebapp, and so the API server is then going to delete that resource because it is defined inside of this manifest here. But what would happen if we had something that didn't have a matching name? So let's go ahead and redeploy that with kubectl apply. And let's say that we changed this manifest file, right? So we've used the manifest file, we called kubectl and created that resource from that manifest file. But now let's say somebody came along and without our knowledge, they changed the name of that resource to something completely different. Well, now if we tried to run kubectl delete with that file name, we're actually going to get an error because we've basically told the API server that we want to delete the resources defined in this manifest file here. And if we explore that manifest file, we can see that the name of the pod that we tried to delete is my cool web app with a bunch of 2s after it. And the API server basically threw us an error saying that it could not find any pods with the name my cool web app with a bunch of 2s after it. So that's kind of an indication to us that that resource either doesn't exist on the server overall, or maybe it just doesn't exist in the current namespace that we are looking at. So what you could do is say, kubectl get pods, and that's going to show you the pods running in the current namespace. Or if you're running in a different namespace, you could actually specify a namespace using the namespace parameter. So I could say like mycoolns, for example. And I don't have a namespace called mycoolns, but if I did, that would return pods from that other namespace instead of the current namespace that I'm operating on. So basically, the API server is telling us that it can't find that pod. So what we can do is come back in and fix our manifest file. And we could do that by changing all of these 2s and just removing those. And then we could save that file and quit. And then if we do a kubectl delete, basically, the API server is going to locate the pod with that name, and it's going to go ahead and delete it. So you can use this declarative approach to create resources as well as destroy them. Now, something else that's kind of cool about these manifest files is that you can define multiple resources in each manifest file as well. You're not limited to just a single resource like what we have so far. So let's say that you actually wanted to deploy 2 completely different pods. Well, in order to define a second or third or fourth resource inside of your manifest file here, you can add 3 dashes in succession like that, and anything that you put after those 3 dashes is going to serve as a completely different resource definition. So I could take this pod spec that we have right up here, copy it, and then paste it in again, and I could give it the pod a different name. So let's actually try it with the same name for starters. So if we have 2 resources with the exact same resource type and the same name, and we do a kubectl apply, let's see what happens. Well, as you can see, the API server actually processed them in order. So when it found the first resource, it went ahead and created the pod. And then when it came across the second resource, it actually just processed it like it would any other resource. So we're not actually getting an error saying that there's, a duplicate resource defined in the manifest. Kubernetes is basically just processing those resources in order as they appear in the file. So that's kind of the behavior that you'll get if you define the exact same resource with the exact same name. However, if you were to try to do something that's unsupported, like perhaps changing the container configuration, so let's try to just rename the container. So the pod resource name is actually going to be the same, but now we're actually just changing something about the actual spec or configuration of the pod. So let's see what happens if we try to apply that. Well, this is going to throw back a really ugly looking error message here. And if you kind of look through this error message, you can see that we actually get back a fairly useful descriptive error message here saying that pod updates may not change fields other than spec.containers.image. So we could update the container image if we wanted to. We could also change init containers as well. We could change the active deadline seconds property on the pod spec, and we could also change tolerations. So those are the only things that we could change if we wanted to. But in this case, if you take a look at the file, we actually tried to change the name of the container from Nginx to Nginx2. And that particular property on the container definitions is not supported for changing. So we would actually have to go back in and edit this file and make a supported change instead. So I'm going to change that back to Nginx, not Nginx2. However, we could actually change the image because the error message told us that we can actually change the image without having to delete and recreate the pod. So what if I was to try something else, like changing the tag on the image to Nginx 1.14.1 instead of 1.14.2? So I'll save that file, and then we'll do another kubectl apply here. And as you can see this time, the first resource definition there doesn't actually make any changes because it was already set to 1.14.2. But when it processed the second resource in the pod configuration, it actually found that the image had changed. And so the Kubernetes API server went ahead and updated the configuration of that resource on our cluster. So instead of seeing unchanged for the second resource, we actually see configured instead. So that's kind of what happens if you are defining a single resource with the same name, the same resource type, but a different actual spec or different configuration options inside of it. So what we could do if we wanted to deploy a second resource is we'd have to make sure that it actually had a different name. So I'm going to actually change the name of this second pod here to mycoolwebapp999. And then let's go ahead and just maybe change the image here to Nginx latest. So we'll have one that's pinned at version 1.14.2 and one that's just using the latest tag. And then we'll go ahead and save that. And now we'll do, actually before we do an apply, I'm just going to do kubectl get pods. And you can see we've only got the one pod with mycoolwebapp. However, if we now do an apply with our updated file, we've now defined a second resource that has a different name. So now instead of reconfiguring the resource with the first name, it's actually creating an entirely different resource. So as you're creating these manifest files, you want to make sure that you're paying attention to the API version, the kind, as well as the name of the resource to ensure that you are distinctly defining resources in here, unless you understand that Kubernetes is just going to process the resources in order, even if they have the exact same name. So at this point, we could continue to iterate and add more resources by specifying another, -- right down here. And then we could define another type of resource. So let's go ahead and try to deploy something like a service resource. So I'll come down to service, and you can see that it belongs to the API group core v1, and it has a kind of service. So let's go ahead and actually just do that by hand. So I'm going to switch back over to my terminal here. We'll do API version and just say v1 because it's part of core. And then for kind, we're going to plug in service. And now we need to also plug in the metadata section because that's going to be required for all these different resources we're deploying. And I'm going to create a service resource with the name my CBT nuggets service. And then after metadata, that's where we can define our service spec. So let's take a look at the service spec right down here. So I'm going to open that up and find out what different properties are supported in here. And let's see. I'm going to search for the type down here, and the type is going to have a default value of cluster IP. However, you also can use node port. You can use load balancer types as well. So I'm just going to plug in, let's say, a type property of node port, and let's see what happens if we just try to deploy that by itself. So we'll do a kubectl apply. And you can see that the first two resources were processed, but because we didn't make any changes to them, it just says unchanged. And then down here, you can see that when we tried to create this service, it actually has an invalid configuration. So if you ever create a resource in your manifest file that does not have a proper configuration, you'll get back an error message that tells you that the configuration of that particular resource is invalid. And it's telling us specifically that the spec.ports child property, so the ports child property underneath the spec section, is actually going to be a requirement. So if we come back in and edit this again, go to the end, and we'll add in the ports child property here. So let's say that we just set ports empty to blah, right? Well, let's try that. We'll do a kubectl apply here. And now we get a totally different error message. So this error message is telling us that there's actually some kind of validation error. So even though we defined the ports property under the spec property on the service configuration, we actually didn't specify it properly. And so it's telling me right here that the ports property right here is expecting to be an array. However, it got a string value instead, and we set it to blah. So that string value is not an array, so therefore it fails validation. So what would happen if we just erased the string and then plugged in an array element? So I'll just do a YAML array here, and we'll say blah. So now we have the array with a single string value in there. Let's try to apply that again. Well, check it out. So now it's complaining, it's saying, okay, I got a string value, but I expected it to be a map. So the ports property, and specifically index 0, so if you think about zero-based arrays, you have index 0 referring to the first element within an array. That first element within the array is expecting to have a map or dictionary or hash table, depending on how you define it. It's basically just a set of key value pairs under that port's first array element. So if we come back in here, we could say, okay, well, I'm going to change this to a map. And I'll say my cool string : blah. So now I've created an array under ports, and I have a map with just a single property and a single value for that property. And let's go ahead and try that to apply that and see what happens. So we'll do another kubectl apply. And now we're going to get a totally different validation error. So now it's telling us that this first array element under ports is missing a required field, and that field name is port. So if we come back in here and change this from my cool string to port and set it to blah, and come back and try to apply it, well, now we're getting a different error saying that it got a string for that port child property. However, it expected it to be an integer. And that makes sense because when you're exposing network ports, a port needs to be defined as an integer number, not a string value, right? So what I'm basically just trying to show you here is that when you're creating these manifest files, the Kubernetes schema for this particular type of resource is going to kind of help you to understand how to properly define one of these resources. And if you want to save yourself this iteration time of, making a change and then trying to apply it, looking at the error message, trying to figure out how to change the manifest, and just going through that iterative process, what you can actually do is just take a look at the API reference documentation here. And if we take a look at the ports child property here, I can actually see that it's an array. So that right there from the documentation tells me that it's supposed to be an array, not just a string or not a numeric value. But then for each array element under ports, it's going to be a service port object. And a service port is going to have a port property that we already set. It can also have a protocol, which is going to be a string. So you've got TCP, UDP, and SCTP as valid values for that. And then you've also got things like target port. So that also is going to be a numeric value that determines what port the service controller is going to forward traffic to. Now, some of these properties will be mandatory and others will be non-mandatory. And so in this particular case, even though the API server told us that the port was mandatory, the documentation is actually not showing us that it is mandatory. There's no indication right here in the API reference documentation that it's mandatory. So to be completely honest with you, this will take some trial and error on your part to understand the proper schema for different types of resources in Kubernetes. And as you get familiar with common types of resources, such as the service resource or the pod resource or the deployment resource, you will eventually over time become much more familiar with the schema for these objects, and you'll be able to easily identify the fact that a port needs to be an integer, not a string, and that under a service controller that you're going to have ports as an array, not just a singleton value, because you could actually configure multiple port forwarding rules for a service controller. So don't be discouraged if you do come across these types of errors. It's just part of the learning process, and it will get you more comfortable over time with Kubernetes, the more hands-on time that you spend with it. So let's go ahead and just fix this really quick here. I'm going to say port 80, for example. And if we try to apply again, now you can see that since we've fixed that service port configuration under the port's child property on the service, we are now able to successfully create that resource. And if we just want to verify that on the server, we can run kubectl get service. That'll show us all the services on our cluster here. And you can see that we did actually create this myCBT Nuggets service with a type of node port. and we've also exposed port 80 TCP on it. However, if you wanted to change the port type, you could just go back to the reference documentation for that service port resource, and you'll notice that we didn't specify protocol, for example. So we could actually come back into this manifest file and then add in a child property under this same array element here, and we'll call that property protocol, and we could change it to UDP instead of TCP. And then if we were to apply that again, you can see that we have configured, not created because the resource already existed, but we configured or changed the configuration of the existing service with this name right here. So if we do kubectl get service again, now you can see that under our port mappings here, we've actually configured it to use the UDP protocol instead of TCP. So that should get you more familiar with how to define multiple resources inside of a manifest file, how to kind of use the error messages to help guide you in how to properly construct a Kubernetes manifest file. I hope this has been informative for you, and I'd like to thank you for viewing.